Okay, just to work out a couple examples here. Number 9 you had in the homework last time, but I told you to skip part D. So I'm going to work out part D for you right now as an example. Remember, that was the problem where the spring vibrates 3 times per second. So we had 3 hertz, which remember are somethings per second. And so for that one we figured out the period was 1/3 of a second, or 0.33 seconds for that. And they're also telling us for the equation, assume that at time 0 x was at maximum. So at time 0 here on the axis, then we're at maximum. So that means we're at maximum stretch at that point. The reason why they're telling me that is then that tells me that this is a cosine wave rather than a sine wave. And remember, with this function up here, it can either be a sine or a cosine wave, whichever one. We're not going to worry about it shifting. So I'm going to write the function of this, the position function, is a times cosine 2 pi over period times t. And then I just have to put in the things that I know for my problem. Well, in this problem, the amplitude is 0.15 meters. So 0.15 meters times cosine of 2 pi over 0.33 seconds for that times the time, which I can reduce that down a little bit, and sometimes we drop off the units to make it a little bit cleaner. 2 pi divided by 0.33 is going to be right around 19 t. And if you want to leave it as 6 pi, you can do that as well. It's still correct. Okay, that is number 9. Number 10, you had one part, or 14 I should say, we had one part that I told you to skip, which was also part D. In that problem you had a mass moving on a spring. It was struck by a hammer. We had already figured out the period in an earlier part, and we'd figured out the amplitude in an earlier part. So now it's just a matter of saying, well, is the position function, sine or cosine, and then what is the modifier, 2 pi over the period times by the time. Well, we know the amplitude here is 0.21. Question is it sine or cosine? If we think about this, it was struck initially by the hammer so that it's moving at the beginning. So if it's moving at the beginning but starting at the equilibrium point, it's got to look like this. In other words, I'm not pulling it up to here or down to here and letting go. It's starting with a velocity from 0. So that tells me it's a sine wave. 2 pi divided by 0.49 t. And if we go 2 pi divided by 0.49, we end up with 12.8 t. And that is the function that describes that oscillation, which is simple harmonic motion.